So basic exponent rule. So let me start asking questions, right? So your teacher in the past have told you says, first of all, let's ask a question. Um, write down on your piece of paper if you think, is anything to the zero power what's a number? Write it down. Anything to the zero power is what? Let me ask a random person. Let's go with you. Do you know what's anything to the zero power is? One. Good. Did anybody put down zeros? You did? Okay, so that's good. That's fine. The answer is 1. Now, your teacher probably told you says it's 1, but do they explain to you why it's 1? Does anybody know the reason why anything to the zero power is 1? So that's going to be a big problem. So for you guys don't understand math, it started your teacher back in 7th grade, 8th grade. Your teacher says, just remember anything to the zero power is 1, but they never explain to you the reason. So for me, like all my students should understand reason because for me, I'm really like passionate about math. Is people should understand some basic information. Those basic information is it's very important. So so let's start why anything to the zero power 1, and that's that. But before that, yeah, let's do that. Let's talk about it. Why anything to the zero power? We're gonna say a. Whereas a could be any number is 1. Why, right? So question mark. But you're gonna say it's math is based on. What do you think math is based on? What? A lot of time people don't understand math just based on patterns. If you understand patterns, everything can win. So let's start with the basic pattern. So let's say 2 to the 4th power, right? We guys know how to write down like 2 times 2 times 2 times 2. That's equal to 16. And 2 times 3rd power is going to be 2 times 2 times 2. That's equal to 8. 2 to the 2nd power is 2 to the 2. 2 to the 1st power is 2, which is 4 and the 2. Now, if you realize it doesn't matter which number I start with, right? If I start with here, 16 go into 8, what do? Divide by 2. Divided by 2. Divided by 2. Now, anything to the zero power, because the next number, 4, 3, 2, 1, the next number is 0. So if you get here, then you're going to divide it by 2. Therefore, that's equal to 1. It doesn't matter what number, though. It could be 3, right? 3 to the 3 to the 3 is 27. 3 to the 3 is 9. 3 is 3. And you just divide by 3 each time. That eventually lead to anything to the zero power is 1. Like starting by understanding some basics. And those are the basics that you need to know. With that in mind, they also talk about exponent rules with the negative exponent rule. So because what's the next number is going to be? 2 to the what? Negative 1. So now it's negative 1. Now it's divided by 2. That's going to be 1 over 2. Does that make sense? And 2 to the negative 2, that's 1 over 2 squared, because that's 1 over 4. 2 to the negative 3 is 1 over 2 to the 3rd. That's equal to 1 over 8. So this is start explaining negative exponent rule. So that's just basic information. A lot of you guys just take. A lot of people even think about 2 to the negative 2 is a negative number. It's not. Anything to the negative exponent is actually positive numbers, unless the number is negative. But and that's only certain thing works. But so those are the basic things that you should start off by understanding. So some people didn't understand what is 2 to the 0 power is, and that's okay. Now you know. From now on, today I'm just gonna treat you guys all like beginner when you learn math, and you learn it in the most fundamental way. Now, some people, when I get to this part, I start asking questions. What would be your next questions? If anything to the 0 power is 1, what would be the next question? What if what? You look at me. No. What will be your next question? If anything to the 0 power is 1, can anything else that you can think of that might not be true? Yes.
0 to the 0 power.
Ah, 0 to the 0 power. So is 0 to the 0 power 1? Why not?
Because you can't divide by 0.
You can't divide it by 0. All right. Let's ask Google, right? So say Google. You're gonna go to Google this. You're gonna say 0 to 0 power. Can be signed without running into contradiction. The 0 to the 0 power is undefined. University matter what's 0 to 0. So let's go look at university performance. We define that 0 to any positive is 0. And so 0 to the 0 power should be 0, but any positive number 0 is 1. So 0 to the 0 power should be 1. We can have both way. Underline arguments, same ideas, blah, 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 blah. What's the conclusion? You guys a good reader? It really depends on how you approach it, right? So, since we study pre-calculus, we're gonna approach in the limit. Have you guys heard about limits before? You have? Okay, good for you. Shouldn't be too many people. But limit is just approaching something really, really slowly. So if you're approaching something slowly, so let's guys have I need some helps with this one. So we're gonna show you a couple ways to approach 0 to the 0 power. First of all, 0 to the 0 power, why is that equal to 1? So there's argument against it, and there's argument against for it. Like when you go to calculus, it's gonna have a different argument because you can approach it differently, different approach. So what we're gonna do is use a very simple approach. So you guys have a phone, you can use that now. So anything to the 0 power, right? That is question mark. Now 0 times 0 times 0 times 0, 0 to the 4th power is what? 0, right? 0 to the 3rd power is 0 times 0 times 0, still 0. 0 to the 1 power is 0. How about 0 to the 0 power? How do I write that? You can't divide it by 0. He says you cannot divide it by 0. That's a good idea because you understand the pattern from before. The pattern from before you divide 0 each time, or divide by 2 each time, divide by 3 each time. But 0 to the 0 power, you kind of like, I don't know about this. So we're going to use a completely different approach. A different approach is to think about what is 0 to the 0 power, but just use a scientific approach instead of just algebra approach. So I need your calculator. And what we're going to do is we're going to start with a number. And we're going to start with 1 to the 1 power. Well, 1 to the 1 power is what? 1, right? How about 0.9 to the 0.9 power? So you guys can use calculator, use your phone, figure out what a 0.9 to the 0.9 power is. What is it?
0.81.
No, that's 0.9 times 0.9. Those are different, so you gotta understand that too. 0.9 to the 0.9, huh? 0. What? 0.909. Okay. 0. Wait, hold on a second. Hold on a second. Let me see that. You do 0.9 times 0.9. It's not really 0.9 times 0.9 though. It's 0.9 to the 0.9 power. Maybe that's a right number, but so you're gonna type in the calculator. You're gonna use this button 0.9 a hat and 0.9 and see what you get. Probably the right number, but it looks like it's doing 0.9 times 0.9. Yeah, you did? Okay, well, so what's the answer?
0.909.
0.90, right? Approximations, right? Okay, let's say it's 0.8 to the 0.8. Yes.
0.808.
Is that right? I don't know. Yeah, so 8 what?
836.
836? Okay, so 836. If you guys don't know how to use calculator, try it on your cell phone, flip your cell phone over, and just do 0.9, and there's a hat thing, like this thing right here. So 0.9, 0.9 like this. So 0.8 to the 0.8 is what? Try it. Try it on your calculator. 0. What? 836, right? So you see the number is going toward what? According to the pattern, what we see is going toward what? It's going towards 0. So let's see if it's true, right? So maybe maybe like, it's not true. So 0.7 to the 0.7 power. 0.0079? 779. Everybody agree with that number? Okay. So 0.6 to the 0.6 power. What would it be? 736. Now, so far, what do you see? The number is going toward what? It's going to where? 0. Still going towards 0, right? So 0.5 to the 0.5 power. What's anybody can tell me what 0.5 to the 0.5 power is? 0. What? 707. See, the number's still going smaller, but did anybody like kind of sense of something, Ian?
The difference between the two numbers is always
Ooh, it's shrinking, right? It's shrinking.
first one, not 983 is a difference of 7, but 83 to 77. 6, 775, 3 to 5, 3 to 707 is well, 3.
So Ian definitely got it to the right thinking. Says, wait, the distance of each number is not going towards 0 because the number is shrinking. It might just stop at 0.6 for a matter. It's not going to go to 0, right? And that's the 0.4 to the 0.4 power.
0.693.
0.693. And you see that it's going down even less this time. 0.3 to the 0.3. Anybody got 0.3 to 0.3?
0.696.
Wait, what happened to the number? It actually went back up. Do you see that? The number actually went back up. So never trust anybody tell you whatever. You gotta see it for yourself. Your teacher told you that anything to the 0 power is 1, just believe it. No, you cannot just believe it. If you don't understand it, you don't understand it. You should question. This is what the knowledge comes in, is to question something. If we just always take to whatever our teacher tells us or whatever our parents tell us, the world will never improve. The only way the world is going to improve is start questioning, even authorities, right? Questioning whether it's true or not true. And sometimes it's true, sometimes it's not true. But you gotta see it on your own. So 0.2 to 0.2 power is what?
0.724.
And now you see the number go back up. 0.1 to the 0.1? 7 what? 94. Now, in order to get to 0 to the 0 power, I'm going to start going down not by 0.1. I'm going to go down divided by 10. Does that make sense? So instead of like that, I'm going to do 0.01 to the 0.01. What's it going to be? 954. Okay, so let's do multiple zeros. So let's do 401, 0.00001 is going to be what? 4 zeros. So it's after a decimal, there's 4 zeros. And just see that going on. And what? It's going to be what?
0.9998.
Right? So it seems like if I going approach to 0 to the 0 power, it's going to a what? It's going to a 1 now. So, and if you don't believe me, type in 80 instead of 4 zeros. So 1, 2, 3, 4, 1, 0.00040, 80 to the 1. It should be 0.999999. And some calculator depends, it will probably go into 1 if you go in about 12 zeros.
0.9999999793.
Okay, so now next time you can try 15 zeros if you want. But you know that it's going towards something. And not only that, so in today I just want to show you how did it work. How do I create equation? Let's say it's some type of equation. Like y equal to mx plus b, like say y equal to 2x or whatever. Any equation, I can resemble it, model the situation. So we're going to talk about modeling in this case. Model is to take something and model the data that you have. Okay, yes.
Power of x.
No. Very good try though. What will be the equation that you can model the situations? Right? Yes.
Y equals x to the power of x.
Very good. What's your name again?
Bennett.
Bennett. Very good job. Y equal to x to the x. See this number, right? The output of this number that we start with 0 here, and we go to 0.9 is 0.91 or 0.909. And you approach. Do you see that output is keep on going down until there's a turning point here, 0.36 to the 0.36, and then start coming back up and it's going towards 0. And according to decimals, the value is going to 1. It's because the number gets so close, they can be something that's, So that's called a approach by limits. You use limits to approach something. So that is, a new way to look at exponent rule now. Some of you guys have never seen this before. Some of you guys seen this before. Great. If you've seen it, great. If you didn't see it, I will introduce to you. I want to introduce you a totally new ideas to see things from the most fundamental ways, even from the most fundamental information that you've been given. So now let's talk about today's stuff, which is basic exponent rules. You need to know all of them. And so let's see what is the exponent rule that you're going to be worried about. Let's start with all the exponent rules. So the first rule is a to the n times a to the n equal to a to the m plus n. So that's first rule. That's called a product rule. The a has to be the same. If you have 2 to the 3 power times 3 to the 2 power, that doesn't work. It's only 2 to the 3 power times 2 to the 5 power that will work. I'm going to explain that in a second. Second, a to the m over a to the n equal to a to the m minus n. Third rules, anything to the 0 power is 1. The fourth rule, very, very important. A to the negative n equal to 1 over a to the n. Because the exponent never prefer to be negative. If you have negative exponent, you should always change it to positive. Regardless of what happened, you should change it always to positive. And this is how you change to positive. It's called negative exponent rules. Now, it's same thing that this rule is never seen before, but is if you is on the here, then it's an over 1. So you can switch side, becomes positive. That's called negative exponent rule. And we kind of already did that earlier. So fifth rule, a to the m to the n. Some people confuse with the first rule and the fifth rule. So this m times n. The dot is times. The last one is actually not exponent rule, but I list the exponent rule just because you use all the time same thing. It's called definition of radical. So this is called definition of radical. Now, what's the definition of radical? Definition of radical is a to the m over n. It's called rational power. That means this n is roots a to the m. So I'm going to write that again because it's kind of messy. It's n roots of a to the m. So this is the 6th rule you need to know, and all 6 rules are super, super important. It's called definition radical. So for the last one, a lot of you guys have probably never seen definition radical. For example, does anybody know what is 8 to the negative 2/3 power is? Good. We're gonna start there, but before that, we're gonna start something else. So I'm gonna show you the examples. Example how things works. So examples. Okay, so what example for the first one? So for example, 2 to the second power times 2 to the third power. Well, what do you guys know? The answer is what? 2 to the fifth power, right? So technically that you could do a slow motion way. This is 2 times 2, and this 2 times 2 times 2, and that's just going to be fifth. So that's 2 to the fifth. But what if you have 2 to the 60, 2 to the 91 power times 2 to the 100 power? Now, the problem of that is you don't want to write down 2 91 times or 2 100 times. It's a very, very big number. That's just going to be 2 to the 191 because the power can add. But base has to be the same. If one base is 2, one base is 3, that doesn't work. If one base is 2, one base is 5, that doesn't work. Only in the number 2. If they have same base, power add. Is that okay? Simple rules. Now this one is going to be 2 to the third power over 2 to the second power. Now of course I can write down like this, slow motion. This can cross it out. That's going to be 2. But that's a bad way to do it. But what if you have 2 to the 100 over 2 to the 91? What would it be? 2 to the what? 2 to the 9. Good. It's not negative 9 because it's always top minus the bottom. It's always top minus bottom. It's always top minus bottom. And stay at the top. Top minus bottom, stay at the top. So you can write down like this if you want to, but they stay at the top. It's top minus bottom. The top power minus bottom power. You cannot do it the other way around. Right? Anything to the 0 power to the equal to 1, I don't explain that. I proved that already. So what if you have 2 to the 91 over 2 to the 100? Yes, Ian? Exactly. Because you'll get 2 to the 91 minus 100. So it's equal to 2 to the negative 9. And according to the exponent rule, you should not have negative exponents. Do you guys remember that? So that's equal to 1 over 2 to the 9th. Good. Just talk about all the rules. Now, could it work with x? Can it work with x? Yes. X to the 91 over x to the 100. That's going to be 1 over x to the 9. Let me know if I'm going too fast. It should be very easy. So because this stuff you learned before, it's not never learned before, but I just want to go through the basic things. So let's say 2 to the a to the 2 to the third power. Now this one's very powerful to using to solve some equations. Now, what's the difference between first one and second one? So this is the first one, 2 to the 2 times 2 to the 2 times 2. This one's different because there's a parenthesis. So that's technically is what? Let's use 2 instead of a. So that could be 2 times 2 times 2 times 2 times 2 times 2. So because of parentheses take a priority, so therefore it's 2 to the 6. Now again, if it's 91 times 100 here, then it's going to be 9100. So those are things that this power can multiply. Going too fast? Yes? Okay. Let me know if you say, can you slow down? Okay. I just expect you guys know already because you guys going through, this is a, my son is going to 7th right now. And they, in their curriculum, they already learn at 7th grade math already. He's doing algebra 1, so yeah, so he inside the previous last year's test already have exponent rule. So I assume that you guys already know, but let me know if I need to slow down. It's fine. The power becomes multiplication. Any questions? No? So you guys like Some people say that this is too easy, it's too hard. That's fine. Just we're gonna reach a medium where like you let me know like, am I doing okay? I'm not doing okay. If you feel like this is too fast, maybe yeah, you gotta think about can you handle this class because this is just the very beginning too. Okay, so you gotta be very conscious. This is the first stage. We didn't cover anything new yet. We just cover something that you know already. Okay. The last one's called definition of radical. Definition of radical is, that one's kind of hard. Okay. So we say 8 to the negative 2 third power. Did anybody know the answer yet? Without using calculator? Yes.
Oh, the actual numbers.
Yeah. No. Ian?
Shows us because if we rearrange it into being 8 to the power of -2, which makes it change, but where I know what I'm trying to say, but I don't know how to explain it.
That's okay. You're doing great, actually. You're not doing bad.
We can just rearrange it so that the 3 is on the outside of the little.
Yeah, so I will rearrange something else first, though. So, for example, you have negative exponent power. I don't like negative exponent power. That's just me. Because I will change it to positive according to the rules. So can I change that to positive exponents? Well, we know the negative exponent. You can switch that. Does that make sense? That's just becomes positive exponent. For numerator, just like I kind of explain to kids, it's like this. If you have bunk bed, anybody have like siblings?
Does a loft bed count?
No, bunk bed. You have siblings, yes, or you have your brother Daniel. I just say if you and your brother are on the things, right, on a bunk bed, right? So Daniel sleep on the top and you sleep on the bottom, and you say I'm feeling uncomfortable, so you can go sleep on the top with your brother, and your brother says I'm not comfortable, I can sleep on the bottom, and becomes happy. So it's pretty much this. So this is the top bunk. He's like, I'm not happy here. I'm negative exponent rule. So I'm gonna switch to the bottom. I'm gonna have positive exponents. So pretty much the same idea. That's a kind of give a good simple analogy. So anytime you have negative exponent, just switch from numerator to denominator, and the exponent becomes positive. Does that make sense? Okay, so that's the first thing. The second thing is you're gonna get to here. So 1 over this is going to be this, and the square root and root 3. According to the pattern, this is the pattern. Now, I don't want you to just memorize that. I want you to just draw a tree like this, right? There's a tree, there's roots, right? I'm not very good at drawing. Don't judge my drawing. And there is a power, which is the sun, right? Power. And the way I kind of think about it is always power over roots. This is the roots. This is a power. And that's use that orientation. So if you have numerator, that numerator becomes power, the denominator becomes roots, and that becomes roots here. Yes?
Is it supposed to be 3 on the outside? For the 1
Oh, yeah. You're right. Sorry. I did it very fast. Good job. So that's supposed to be 3 and this 2. Thank you. Now, what you're going to do is you don't want to do power first, because in order for tree to grow, you're going to grow roots first, right? So what you're going to do is you're going to do roots first. And if you do roots first, that will give you what? Something times something times something is equal to 8. The same thing, it has to be 2. 2 times 2 times 2 is equal to 8. So therefore, 2 to the second. And the answer is 1 over 4. And there you go. Let's just show you how to do that. It's 1 over 4. So even something like this, you haven't learned. That's okay. Now we just talked about 6 different rules, and all those rules are super important for your SAT because you've seen this question all the time. Okay, so now let's start with the rules. So what if you have 3x to the 4th times y to the 2nd times 2x to the, I don't know, 3y to the negative 4. Okay, so how do I multiply those two things together? This is one of the SAT questions that you might think later. Yes. So what do you think the answer is? What do you think the answer is? Does anybody confident to tell me the answer is? No? Yes.
First one would be like 3 and y 6, power 6.
No. Nobody can tell me the answer for this one? All right, let's start with simple thing. This is a two parentheses next to each other. Are they addition or subtractions?
Multiplication.
Okay, so good. I was trying to trick you, right? So they are multiplication. Good. So that means 3 times 2 is 6, right? How about x4 times x3? Yeah. X to the 7. Good job. That's it. How about y2 times y to the negative 4? Negative 2. Now, what do we say about negative exponents? Yep. 6x7 over y squared. Does that make sense? Is that easy?
Yeah.
What?
Y2. Y negative.
Yeah, y2 times y to negative 4 because the first rule, that 2 plus negative 4 is going to become negative 2. You add the exponents. Exactly. Let's try another one. So 4x to the negative 2, y to the negative 5, times 2 to the x to the 5, y to the 2. Liam's not here, right? Okay, so Rylan is here. Rylan? Okay, that's Rylan. Jesus is here. Astrid? Okay. I know this 3. Bennett? Okay, got it. Jade? Got it. Julia? Who's Julia? I only call on the people I don't know. So see your face. Okay, now I know who you are. Hopefully. Armin?
Here.
Okay. Ines? Ines is not here. Oops, it's not. Austin?
Here.
Brandon?
Here.
Mariana? Okay. Andrew? Okay. Cohen? Okay. Sarah?
Here.
No, the Sarah Nieva. Okay. Kalian? Kalian? Okay. Charlotte? Neely? Madison? Astrid? Okay. Jayla? Aiden? Okay. Neil? Safa?
Yeah.
Anika? Okay, got it. Okay, so the answer should be what? Y to over y to the 3. Okay, y to the 3. Yes, this is good. Correct. So over y to the 3. Did everybody got that? Okay, good. Now let's go with the next one. That says 2 for x to the negative 3, x to the negative 2, y to the 5, y to the negative 2. And I want you to simplify this. All right. Anybody comfortable with the answers? Y to the 7. And what?
Over 2x.
2x. That's good. That's good. 2 and 4 is 1.5. That's simplify. So 1 over 2. I still split up top, numerator, and bottom. So x to the negative 3 minus negative 2 because top minus bottom. Y to the 5 minus negative 2. Is that okay? So 1 over 2. X to the negative 1. Y to the 7. And the x is negative 1, so therefore is y to the 7 over 2x. That's a good job. Now today's question is going to be a lot of different exponent rule. You had to go back to the rule and see if you can follow it. But some of the easy ones like this one, a lot of people get it wrong. So now it's parentheses to the square. This I will use rule number 5. And not only I use rule number 5, I'm going to put a 1 right here. I use a blue marker to show you that I put a 1 over there because 2 to the first power is present. It's not 2 to any power. It's not 2 to the 0 power. 2 is 2 to the first power. Is that okay? Now, according to rule number 5, right? According to rule number 5, this one's going to multiply. This 1 and 2 is going to multiply to 2. And this negative 2 times 2 is going to be x to the negative 4. Y to the 8. And only x is a negative power, so it's going to be 4y to the 8, x to the 4th. You're going to have all kind of different exponent rule today, even including fractions. So you got to take account into that because adding and subtracting fraction is something that you can do now. Your homework will be probably posted sometime around about my planning period. So if you check out today, now if you didn't see your homework, ask somebody else to repost again if somebody else see it. Yes. Yep.
What's the number right on top of the x at the bottom right?
4y8